So a man by the name of Maxwell Planck found that whenever we take and use this number, this is the relationship between the frequency and the energy of the photon, as well as the speed of light divided by the wavelength, which gives us the frequency and the energy of the photon. So out of equation 1, 2, and 3, we are given frequency. We want to find the energy of the photon. Which equation do I use, 1, 2, or 3? I'll open up the chat logs at home in case you're chatting. Equation 1, 2, or 3? We want the energy of the photon. We're given the frequency.
Is it 1?
Yeah. Energy of the photon equals Planck's constant times frequency. So even though these look crazy, it is just basic algebra. H times F, which is 6.626 times 10 to the negative 34th joules seconds times frequency. 1.55 times 10 to the 19th. Seconds to the negative 1 means it's on the bottom per second. So that means seconds and seconds are going to cancel out from Planck's constant, the second here, and the per second here are canceling out. That will give us joules. I forgot my watch calculator today. Times 10 to the negative 34th, even though you can't do scientific notation anyway, that I know of. 6.626 times 10 to the negative 34th times 1.55 times 10 to the 19th. We get 1.03 times 10 to the negative 14 joules. So that's the energy that the photon has that is emitting this frequency of radiation. So if we take a look here, which equation are you going to use for next Thursday? This is your homework for Thursday. Given the lambda or the wavelength, what is the energy of the photon? Are we using equation 1, 2, and 3, or some combination of the two? 1, 2, or 3, or some combination?
Is it equation 2?
Equation 2, right? Lambda's on the bottom. We have Planck's constant, and we have the speed of light. Speed of light 3.00 times 10 to the 8th meter per second. That's the same speed of light that you see in M equals E equals MC squared. That is the speed of light in a vacuum. You're to do that problem for Thursday of next week, as well as we're going to do the bottom half. You're going to do part of it for homework, but I'm going to take you through at least 2 problems. It says that energy of a hydrogen electron, it depends on its location outside the nucleus. So how far, again, away from the nucleus it is, that tells us how much energy it has. Niels Bohr derived the equation that assigns an energy value based on the number of the energy level. And that is negative 2.18 times 10 to the negative 18th joules divided by the level number squared. So the level number for the first level is 1. We call that e to the first, or e sub 1. So we're going to take e sub 1 equals negative 2.18 times 10 to the negative 18th joules divided by 1 squared. which is 1. So the first energy level has negative 2.18 times 10 to the negative 18th joules of energy. E sub 2, n equals 2, negative 2.18 times 10 to the negative 18th joules. And we're going to take that divided by 2 square. 2 square is 4. We're going to take negative 2.18 times 10 to the negative 18th divided by 2 square. We get negative 4.45 times 10 to the negative 19th. I'm sorry, 5.45, not 4.45. I can't read. 5.45 times 10 to the negative 19. Cool. So what are you going to do for the next one? Well, instead of having 2 square, what will you have on the bottom?
Three square.
E3. Yeah, 3 square on the bottom. And then 4 square and so on. That will give you the energy of each level. That's the energy of the first level, energy of the second level, third level, and so forth. By knowing that energy of each of these levels, if an electron has the energy of the 4th level and it drops down to the 1st energy level, now it only has the energy of the 1st energy level. So it's going to emit a photon of all of that energy. From dropping from the 4th to the 1st, we'll be able to then calculate that energy and then be able to determine the wavelength or the frequency of that photon it's emitting. And that's our goal for probably next Friday, Thursday or Friday. So meet quickly on Wednesday. Well, you're going to work on this until Wednesday, number 2, and then the rest of these 3 problems right here. And then Wednesday, you're going to also review for the quiz. It's all the way up to the electron configurations. So keep that in mind. You'll have to do electron configurations and talk about how many electrons the p sublevel can hold, stuff like that. That's all I've got for now. But if you do have questions, by all means, stick around. Otherwise, you're more than welcome to go work on that stuff. And remember, you did so well this first part of the semester that you guys get Monday and Tuesday off. So I will see you next Wednesday for a short one. Have a great weekend.